In this video, we're going to pick up where we left off in creating this rleast-squares package. Now, sometimes we'll have code that we want to actually implement in C++ because the code we're running in our R package, we want it to run much faster. So let's say that in this least-squares function, remember the heart of it was this function fit_ls we wrote. It was a pretty short function to write, but it does call solve and cross-prod twice, cbind, so I don't know, maybe there's potential to make it faster if we could implement it in C++. Well, there's this really nice R package called Rcpp that allows us to do this. And litr can be used to make it easy to use Rcpp together within the context of an R package. So let's see what that looks like. If we go to the litr website under R package templates, one of the templates is called make an R package with Rcpp. Okay, we could just have a quick peek at what that looks like if we click on this R markdown file. Okay, so this is an R markdown file that shows how to make an R package that involves Rcpp. And actually things are very much like they were for regular R packages without Rcpp. The only difference is we have a code chunk where instead of R here, it says Rcpp. And then there's some Rcpp specific lines. Then we have our documentation, which looks a lot like what regular documentation would be in R Oxygen, except it uses // and then we have our function. Once that's done, actually, we can call this function. Here we're defining a function called alternate signs. We can call it just in a regular R chunk, as we've done here. For rleast-squares, though, we're going to want to use something called Rcpp armadillo. And what is armadillo? Well, armadillo, it's a C++ library for linear algebra and scientific computing. It's very convenient when you're in C++ and you want to work with matrices and vectors and be able to use all the functions we like the Cholesky decomposition and other matrix operations. Rcpp armadillo is an R package that lets us do that. And we have a litr template that allows you to have an R package that incorporates armadillo into it. Okay, so I'm going to open this one here. And it's pretty much exactly what we saw for Rcpp, where we have a code chunk that has Rcpp written here, but some of the details are a little different up here. And furthermore, we're going to have one more code chunk that has a use this command for use Rcpp armadillo. All right, you can follow the template to see the details, but I'm actually going to demonstrate it right now for our least-squares package. Okay, so just a reminder, we defined this main function for fitting least squares, then we tried it out, and we made a plot to see that it looked right, and then we compared it to what LM would have given to make sure we're getting the same answer, and then we wrapped this all together in a test. So now let's add a section implementing this with Rcpp armadillo. Okay, so we could say, let's see if implementing this in Rcpp armadillo will lead to a faster solver. So I've actually already done this. It's in my clipboard, so I'm just going to paste it right here, and I'll go through what I did. Again, we have a code chunk that has Rcpp written here, and then we have some specific lines for Rcpp armadillo. And then now here is my implementation of the fit_ls function. I'm calling it fit_ls_cpp, but it's structured in the same way. There's an x, there's a y, and then there's an inter, which is either true or false. Okay, so the function potentially, depending on inter, whether it's true or false, will add a vector of ones as the first column of x if needed. Otherwise it doesn't. So this function arma join horiz is basically like cbind. And then it calls arma's solve, which takes a matrix and a vector and returns that. The only other thing to remember is we need to have this use this line, which just also helps set everything up so it'll work in your package well. Okay, so let's just try knitting, make sure that works. Now when we press knit, remember there's this litr document call at the bottom of this. Usually the purpose of that is to make sure that all the functions, when somebody does question mark name a function, that the man page will show up, the help page. But actually in the context when Rcpp is in your package too, this call document also compiles the C code. Okay, so this popped up. This is the HTML file that was created. And close this. If we look at the R package itself, we see that in addition to the R folder, there's now an SRC source folder, and this has code.cpp, which has the RCP code we just wrote. Okay, just like before, we can install this if we like, and let's do that. Okay, and then we can see, here we go. Here's our new function, fit ls cpp, question mark, and I can see that, this help page came from the information I had here. Okay, so let's try this out. So let's see if this is faster than our fit ls function. Okay, so for that, there's this rpackage micro benchmark, so we'll call that. It makes it very easy to compare different lines of code. We could say, well, what if somebody just tries, fit ls x comma y? So we'll call that the fit ls version. Somebody else might call our function, so this new function, fit ls cpp, we can just call this bench, and we could print out bench. And we could also make a plot of bench. So let's do that. And now we can press knit. Okay, scrolling up, we have this new section implementing this with Rcpp Armadillo. We have that benchmark function. And so it ran the functions 100 times and compared the average run times of the two. And so sure enough, we see that our implementation in Rcpp was maybe like 3 times faster than our original implementation. We can also see it in a box plot. So from here, we probably want to make sure that actually this function is doing the right thing. Like, is it correct? So we could create another test. Maybe I'll do that. I'm going to just copy this here. Okay, so let's make sure that this RCP implementation agrees with fit ls. So now we're asking if fit ls CPP matches this. And so we have fit using CPP and fit using this other one. And now we can compare the two. I don't think this is going to actually work. We'll see. Yeah, okay, there's a test. There's a test failed. What I realized, in fact, I can just run this in the console to show what I realized, that this actually, I think it is basically the same, but it's not exactly the same. So, okay, it doesn't see fit ls. Let me just go up to fit ls, run that. Okay, now that's defined. So now if I run this one, okay, so I've run the two. And so why are they not the same? Okay, hold on. I need to run this. Could not find the function. Right, that's what I need to do. Library are these squares. And now I should be able to find the function. There it is. Wait, there it is. Okay, great. So now I have the two. Let's have a look. So there's this one, and there's this one. And sure enough, it looks like the numbers are matching, but this is what I realized, that this CPP function is actually outputting a 2x1 matrix rather than just a vector of length 2. So let's just add an as.numeric around the side here. And now this should work. Press knit. And when we use RCP, it's a little slower because it has to compile when we press knit. But sure enough, this test passed. Great, so we've shown how to use Rcpp armadillo in the context of an R package when you're using litr.